Okay. Hello everyone. So this instrument is the Dewey ring tensiometer. It measures the surface tension or the interfacial tension between two liquids. Now to define the surface tension or to know what surface tension is, when we have a liquid in a beaker, the molecules in the bulk are stretched or attracted equally by the adjacent molecules of the same liquid or the same compound. But the ones on the surface have the same liquid on the bottom, but on the top it has some other liquid. So if we have water with air, so the molecules on the surface would have water on the bottom pulling it downwards, but the one above the surface are air. So there's an they are not pulled equally, and that causes a stretch or a force on the surface of the film or the surface of the liquid, and that's what we call surface tension. And the reason this instrument is called Dewey ring tensiometer is because of this ring. So this ring is called the Dewey ring, and we use this to measure the surface tension. So first things first, we need to clean this ring. And to clean this ring, what we do is we just put a flame of propane on the surface of it and try to burn all the impurities on it. Yeah, it's difficult with the gloves. So in the lab, you are not supposed to do this. One of us would help you out. After we clean this ring, we put the ring on this instrument like that. Then we put our liquid here, and we make sure that this knob, the one on the bottom of this, is all the way up. Then we take the entire stage up until the ring is immersed in the liquid. Once the ring is immersed, we have to look at this small metal thing here and make sure that it's in line with the line on this glass mirror on the back of it. If it's not, we just move these weights. Yeah, so we move these weights and try to get the metal thing in line with the line on the mirror on the back of the metal thing. Once we have that, we make sure that this scale is at 0 0, and the way we adjust that is by using this knob here. So we make sure it's at 0 0, and then we bring the ring on the almost on the surface but not touching the surface. So when the ring is in bulk liquid, we don't have any force exerted on it, but when it's at the surface or at the interface, there is going to be the surface tension acting on the ring. Okay, so this is almost on the surface now. Now we have to do two things simultaneously. One, we get this stage down. Now when the stage goes down, the surface tension is gonna pull the ring, and this the metal thing is gonna move downwards because of the pull. When it does that, we have to use this knob to get it back to the to where the line is. So we have to align it with the line, and we do that in small incremental steps until the ring finally pops off the liquid. So let's do that. So I'm pulling the ring down a little bit and then adjusting the knob on the right to get it back at the line on the mirror, and we do that very slowly in small incremental steps. Okay, so the ring has now popped off, and once that is done, we measure the apparent interfacial tension or apparent surface tension from this scale. So now it's 34. So that's our apparent surface tension. Now what we do is we have to, so this is not the true surface tension, and because there might be a lot of issues with the measurement and it's not pretty accurate, so we have to use a correction factor to correct for those issues, and for that we have the two graphs here. This one is for the 4 centimeter ring, this one is for the 6 centimeter ring. So if we look at our ring, it's 6.16 centimeter in circumference, so we have to use the graph on the bottom. So the x-axis here is the apparent surface tension, which is P, divided by the difference in the densities of the liquids. So let's say our x value is 500, and now each of these lines are for different r by r values, 60, 50, 40, 30, starting from the left. So this is 60, 50, 40, 30. So for us the r by r value is 50.8, so we'll use the line for 50, which would be the second line from the left. So assuming our x-axis is 500, we kind of just go upwards to the line and go here. So it's gonna be about 1.2, our correction factor. And then we have an equation on the second page where the true surface tension is S, equal to the correction factor multiplied by our apparent surface tension. So 1.2 multiplied by 34, what we got, and that's gonna be our true surface tension. And yeah, that's pretty much it for this lab.